Welcome everybody, and thank you for joining us today for the Raise Farm of the Future webinar. So the topic today of this month is future farm fuels, and we are joined by three speakers. We've got Alistair Walshaw, Neil Tierney and Kit Franklin, with Richard Guterbock chairing the session. So just before we start, I'll hand straight over to Richard in a second, but we've got the Q&A function open. So I would encourage you all, sort of as the webinar, as we get on with it, and if you've got questions, please do sort of type them in as you think of them. If there's anything sort of really pertinent for one particular speaker, we may sort of tackle it there, but if not, there will be plenty of time at the end to go through your questions. I think that's everybody. So everything. So thank you. And Richard, are you ready?
Thanks very much, Tash. Thanks for organising the event, and thanks, Alistair, Neil, and Kit for joining us. I'm Richard Guterbock. I'm one of the Farm of the Future team at Raise, and I just want to make a quick introduction. We've got some slides coming up, I think. So just a bit of background. The need for farming to look at alternative fuels and powertrains for tractors and heavy machinery was highlighted in the RASE Farm of the Future report, which came out in 2023. The slide that you can see is one of the infographics that were produced for the report, focusing this one particularly on the need for farmers to engage in, or the opportunity for farmers to engage in, on-site energy generation, whether it's bioenergy such as biogas, biofuels, or potentially wind, solar, etc. So, you know, a major opportunity for farming to be part of the sort of decarbonisation of the rural economy. And part of this, if you can switch to the next slide, please, Tash. Part of this is really looking at future fuels and powertrains for agriculture. And this is one of a series of events that we've been laying on, looking at how farming is going to move away from a heavy reliance on fossil fuels in the supply chain. And it's clear that we need greater momentum towards the use of clean fuels in agriculture and other rural applications. And you know, it has been highlighted by a number of people that agriculture is a bit of an outlier when it comes to having subsidized red diesel as its main vehicle fuel. And, you know, in the next decade, we're going to have to see a move away from fossil fuels. And that needs to involve a dialogue between OEMs, the manufacturers, the farming community, regulators, and the government to actually create a pathway for that to happen. And I think one of the key things we need to highlight is that, you know, it's going to be inappropriate for farmers to be required to use novel powertrains, particularly perhaps electric, which can be highly inflationary without necessarily meeting the performance needs of the sector. So we're going to look at gas and other fuel alternatives for agriculture, and then end up with a session on robotics, which perhaps is the one area of future farm vehicles where electric power trains are going to be more appropriate. But certainly for heavier duty stuff, replacing fossil fuels is going to require internal combustion engines for some time to come. So starting off, we have Alistair Walshaw, who has been involved in the development of alternative powertrains for tractors for a number of years, and was the lead at Case New Holland on the development of their gas tractors. And he's going to talk to us about the range of fuel options that there are available for tractors in the foreseeable future, and how that transition to gas fuels may happen. So, Alistair, over to you.
Thank you, Richard. Let's just sort out the screen share. Okay, hopefully it's working.
Yep.
Right. Okay. So just to add a little bit more to my background, I'm a farmer by birth. I'm an engineering manager by profession. So I'm probably in the worst combination, in that I believe that I know how to tell people from both these sectors how to do their jobs properly, but I don't actually do either of them myself. So biomethane hydrogen on the farm, what could possibly go wrong? Firstly, why are we even thinking about this? It's probably even more of a question in the light of the more recent instructions coming out of the White House. But regardless of that, I think it's generally accepted that agriculture is a notable contributor to the greenhouse gas emissions. Globally, agriculture accounts for around about 20% of the greenhouse gases, which is comparable to the impact of all the mobile vehicles in the US. In the UK, agriculture represents about 12% of our total emissions, so that's equivalent to about 80% of the passenger cars. So these figures highlight the need for agricultural sectors to take action in mitigating its impact on climate change. However, agricultural emissions are not only from fossil fuel usage. In fact, the primary originate from livestock and soil husbandry, with the emissions from farm machinery being a relatively minor contributor. So it's using the 80-20 rule, it could be argued that achieving zero emissions from machinery may not make any significant impact at all. So what's the point? It won't change livestock emissions. And while technologies in precision farming and automation will benefit soil husbandry and management, these benefits are largely invisible to the general public. Big machinery, however, is a visible symbol of agricultural industry's environmental footprint. Therefore, addressing the fossil fuel usage on farm is essential not only for reducing the greenhouse gases, but possibly more importantly, for demonstrating a commitment to sustainable practices. The NFU has established a challenging goal for UK agriculture to achieve net zero emissions by 2040. And this is going to be a significant task, especially considering the reduction in ag emissions over the past 30 years is estimated to be around 40%. So in the quest to reduce emissions from agricultural machinery, many different energy sources have already been proposed. Diesel, with its plentiful and economic supply, has been the universal solution for the past 100 years, but it's now recognized as disrupting the ecological balance on our planet. The use of alternative fuels, primarily battery electric for passenger cars, is somewhat in advance of heavy-duty vehicles, and while a simple cut and paste option is the solution in some people's minds, agriculture has some unique challenges to overcome. Seasonality. In most farming situations, the use of energy has peaks and troughs, which depending on type of farming can be daily, monthly or yearly. And then there's power requirements. Due to many factors, including task and soil type, weather conditions, the power requirement varies throughout the day, throughout the year, etc. And it's these factors that complicate further the energy delivery schedule for an individual farm enterprise. Most of the technical solutions being proposed provide a practical working machine, but the common challenge of vehicle range is always a talking point. Well, I should probably say it's not really a talking point. That's some of the problem. It's rarely spoken about in basic engineering terms, like litres or kilograms per kilowatt hour or per hectare, but rather in nice marketing words that loosely indicate the vehicle will do a working day of average work. This range anxiety, like found on on-highway vehicles, is somewhat exaggerated in that the benchmark fossil fuel vehicle has a much bigger tank than is actually required to fulfill this average day's work. On the slide, I've tried to highlight this with a 200 kilowatt diesel tractor. There's a fuel tank capacity of around 600 litres that will easily do over 24 hours of average work, so much more than the average day. The blue numbers show the installed numbers, so across the top, in some of the various alternative fuel vehicles that have been shown in recent years. Some of these are my best guesses due to the numbers not ever actually being published, just hinted at. Oh yes, you may notice in the middle there's a nice orange tractor. This is a modern fuel cell tractor from Alice Chalmers back from 1959. If we now compare the numbers with the sort of capacities in the green that are required to equal the energy storage of our benchmark product, it's easy to appreciate that in many areas we are some way short, not only in energy terms, but also in real estate space on the vehicle, which in some cases is now bigger than the vehicle itself. The John Deere battery, so in the battery section, so there's this square green John Deere arrangement, is in effect a 1 megawatt battery on wheels, and it weighs 18 tons. Now, this doom and gloom is not a reason to give up, but perhaps we do need to modify our expectations of vehicle range and include other benefits when looking at the complete energy ecosystem. The other big issue for agriculture and off-highway vehicles in general is fuel supply and infrastructure. Generally, we need the fuel to be delivered to the point of use. Yes, the farmyard is used for bulk deliveries, but in most cases, the real point of use is actually in the field, as we don't want to be continuing running up and down the public highway with large, bulky, and often very dirty equipment. In addition, farms, by their nature, are generally located in very rural locations, meaning that grid locations and urban customers take for granted, like electric, gas, water, and even internet, are not necessarily either available or reliable. Any search for an acceptable low-carbon fuel alternative needs to address these constraints. If we look at electric vehicles, as they encroach on larger power-hungry activities, what is considered an on-highway fast charger of 130 kilowatt capacity will need a good three-phase supply, which is a rarity for many rural farms. And even then, the tractor will be on charge for roughly the same time as it is working, 1 hour on, 1 hour off. I will gloss over the John Deere 1 megawatt machine, which would draw the same daily requirement as approximately 200 houses, so a small village per tractor. And then we still have the challenge of field delivery of electricity, one option that has been shown as a long extension cable. For hydrogen, the current options are compression and liquefaction, the former requiring multiple HGVs to carry the quantity required, roughly 8 full Arctics is equivalent to 18,000 litre diesel tanker, while the latter requires some very sophisticated and expensive equipment to keep the hydrogen below minus 250 degrees centigrade. The key advantage of hydrogen and other gases, however, is the quick fill ability, as fast and potentially quicker than diesel. Biomethane requires similar equipment to hydrogen, but the storage pressures and temperatures required are somewhat less challenging. So if delivering the fuel to the farm is a challenge, why don't we make it on the farm? This could not only segue into energy independence, but may also add diversification into the energy farming. Wind farms and solar farms are now quite commonplace, although they do have some limitations of natural geography and suitable grid connections that enable the peaks and troughs of energy generation demand to be matched. Also, a sizable array is most likely to be needed. For 1 megawatt of power, wind turbines need a clear area of between 2 and 40 acres, depending on topography. But luckily, only a small area of productive land is actually affected when in operation, whereas solar panels do require about 5 acres per megawatt of productive land. And of course, these technologies have varying levels of public support and perception. Hydrogen fuel can also be generated locally. However, as it is not a naturally occurring element, it has to be extracted from various feedstocks. And this takes resources in the forms of raw materials like methane or deionized water, along with a lot of energy. Compressed green hydrogen by electrolysis needs approximately 9 litres of deionized water and 55 kilowatts of power to produce 1 kilogram. If we look at biomethane, its production through anaerobic digestion of organic matter such as livestock manure, crop residues, and other organic products. What I call industrial biomethane production facilities are major businesses in their own right and are strongly focused on energy production for injection into national grids, be that gas or electric. They have not generally been set up to produce vehicle fuels, and the grid connection requirements generally means they are located in the less rural farming environments. On the other hand, there are now a small but growing number of companies, including the likes of Benham from Cornwall, Cube Renewables, and the Biofactory from Somerset, who have developed microsystems that focus on manure management challenge. In following this approach, the cost of manure management system is effectively transformed from a liability into an asset, reducing the carbon impact of all three of the ag emission culprits: manure management directly, soils and through nutrient and regenerative agriculture, and the replacement of fossil fuels, and positively impacting the profitability of the farming enterprise. These radar plots and comments below them try to position the potential of the current alternative fuel offerings. Biomethane is a fuel that is here and now. It is commonly available and reasonably well understood. In many cases, it just has to be captured, and with the requirements for auxiliary stores to be covered by 2027, maybe a trick has been missed in not optimizing the actual benefit of this fugitive energy supply. Hydrogen, I believe, is unfortunately a year or two off. When I was at university some years ago now, my tutor informed me that hydrogen would be a fuel of the future. I did not disagree with him then, and I still don't today. But I believe that farmers could have a key role to play in the production of green hydrogen, both for themselves and be a key supplier to other industries. But this will need some further technology developments that are a good fit with a farming food system and not one that displaces food production. At a vehicle level, common vehicle architectures and structures for gaseous fuels could be possible. A methane ICE vehicle can already, with very minor changes, run on hydrogen. And interesting enough, a compressed methane-powered vehicle tank arrangement and a compressed hydrogen vehicle with basically the same tank layout will have a very similar vehicle range. So this may be a bit of a development. With a bit of development, dual fuel products could be an option that will at least minimize OEM's manufacturing complexity. There are many challenges in the adoption of renewable fuels. These are particularly prevalent in agriculture, where farm variety, seasonality, remote locations, and power demands make it one of the hard-to-abate candidates. Integrating hydrogen and methane solutions have the potential to significantly reduce the emissions in the sector. These solutions can provide economic benefits through cost savings in energy production and consumption. Successful case studies showing hydrogen implementations illustrate its potential effectiveness, while real-world examples of biomethane solutions available today highlight their viability and advantages in energy production, sustainability, regenerative agriculture, and circular economies. Hydrogen and methane technologies both have potential to enhance energy efficiency, minimizing waste and maximizing output. And the integration of these solutions can open up new market opportunities, driving innovation and investment. Supportive government policies are needed to accelerate the innovation and transition to greener productive farming, and farming businesses must remain sufficiently profitable in order to invest, improve, and become part of the solution if we're going to succeed on the net zero ambition of 2040. So let's not allow perfection to get in the way of progress. Unfortunately, we don't have another 100 years to perfect the system. Thank you for listening.
Alistair, thank you very much for that quick trot through the sort of options that are out there and being explored as sort of future fuels and future powertrains for agriculture. A lot of content in there, and hopefully people can refer back to the slides. We're going to move straight on to our next speaker, who's Neil Tierney. Neil is the CEO of HiKit and is an established energy entrepreneur and currently working very closely with JCB, looking at the storage and supply of green hydrogen for agriculture, construction, and other sectors. So over to you, Neil.
Thanks very much. We're just going to share the slides. I'm getting some assistance as I'm out and about today.
Yeah, Tash, are you able to put the slides up?
Sorry, Alistair, I think I need you to stop sharing to allow me to do it.
There you are.
Thank you. There we go. Hopefully you can see that.
There we are. Yep, see those now. Over to you, Neil.
Excellent. Thanks very much. We'll just pause quickly on this first slide. Thinking about today's presentation, I was trying to figure out how I can take people through this without it sounding too salesy. And so I've taken inspiration from the great John Craven. And so we're going to have a news round kind of bulletin, which I seem to remember was 10 minutes in the 80s, and it'll be 10 minutes in the 2020s. So yeah, my role is heading up a new joint venture business called HiKit. My background, I'm an engineer. I've run a number of startups myself. Demand side management, so the grid is an area I know well, and then moved into electric vehicles, and then had the opportunity to hop over into hydrogen. So I was actually parachuted into a previous company called NanoSun, and some of you that follow hydrogen closely will probably know about that business, and it was a forerunner on hydrogen delivery. And the previous presentation was perfect, setting me up for my presentation. And that business ultimately was sold back to the major investor. And there's a good example of probably a business that went a little bit early. Hydrogen's obviously taking a little bit longer, but I've been in hydrogen now for a couple of years, and it's a super interesting sector. It's at one level quite complicated, at one level very simple. So I'll just show you a basically news roundup of some of the things that have been going on for the past couple of weeks. And one of the reasons to do that is there's quite often questions, and so some of these pages and links that I show you, you can go and investigate further. So if we can skip on to the next page, that'd be great. So this is a piece in Energy Now, dated, actually this is dated in January. So everything I'm going to show you is in the past 2 months, and it really is sort of live. JCB, I've been working and basically initiated HyKit. Actually, it was the 1st of March last year, so it's about a year old. JCB, as many of you will know, developed a hydrogen internal combustion engine building on their long, rich history on diesel. And but they don't want to be in fuel. They've never wanted to be in fuel. And they also recognize that refueling is a big barrier in hydrogen. And so they've been very keen to set up a joint venture business that can both deliver to what they're doing, but also deliver beyond just their machines. And so actually just before Christmas, there was a joint venture signed between a private equity company called HyCap, which has a bunch of LPs. One of them is JCB, and Hydra B, which is Joe Bamford, Lord Bamford's son's investment company, and JCB. And so very exciting, very live. And the idea is that HyKit can close the gap on mobile delivery of hydrogen to hard to reach sites, and can do that initially for JCB and then do that for other companies beyond JCB. So you can go, if you Google JCB and HyKit, you'll see a bunch of articles and you can read about it. So we move on to the next slide. And I just want to point out that the work that JCB's done actually builds on a sort of, interestingly, a failed attempt at looking at hydrogen fuel cells. So they did attempt a large excavator. And as some of you that are familiar with hydrogen technology, fuel cells are still, they're very expensive, they're heavy, they don't love harsh conditions. And so actually that was a failed project by JCB. I'm sure they'll go back to look at fuel cells again in the future, but what they did is invested a lot of time and money in really a ground up development of a hydrogen internal combustion engine. JCB's non-exec on my board is Bob Wormsley. Bob has been with JCB for 43 years, worked for all 3 chairmen, and is basically Mr. Engine. So while they looked at fuel cells, it didn't work out, and so they went back to look at a hydrogen internal combustion engine. So if we just move on to the next slide. And here it is. So I think, you know, various numbers are kicked around, but I think if you think about a sort of £100 million commitment to the hydrogen internal combustion engine, that'll be not a million miles off the mark. And again, there's a bunch of reading you can do on that engine. I know everyone's always interested in efficiency and particulate. And there's some good information kicking around if you are interested in digging into that. So I found a piece at iaps.co.uk, which is a DESNES study, and there's a couple of numbers in that report, so you can Google that. So this is H2 ICE, so H2 ICE technology. You know, in the study they did, and this was out in November, their summary is 14 to 20 times lower carbon emissions than diesel engines, particulate reduction of 98% versus NOx on particulate versus diesel, and then basically 99.95% reduction in CO2. So it's not perfect, but it's a huge step forward, and I think they've done a great job on that project. So next slide, please. And some of you who have been watching the news might have seen the King. This is the type of lucky thing which, if you're running a startup, is fantastic and has never happened to me before. And I didn't know about this until I saw it on the news, which shows you the level of secrecy that goes into these things. So the king turned up on, was it Monday or Tuesday? I can't remember. It's been a long week, possibly Tuesday. I can't remember. Anyway, he turned up, and it was principally to celebrate 80 years of JCB, secondarily to celebrate the millionth backhoe that's been produced, and the third part was really to celebrate the work that's been done in hydrogen. So if you go on YouTube, you can actually see a pretty uncut, unvarnished 20 minutes of the king poking around JCB and actually using the high-kit refueler, which is on the right there. And I'll talk a little bit in a second about the business model for that. But yeah, a great piece of PR. And if we just move on to the next slide, please. So this is just, I wanted to put up an image of how it works. And so in second half of 2024, JCB diggers, so they've got 3 units at the moment: a backhoe, a load all, and a generator set. And the way this works, I think the previous speaker was sort of talking to this, is the aim of my business is to make squirting hydrogen into a target machine as simple as diesel. And so the idea here is you have a containerized high pressure set of vessels. This version is on a single trailer that, imagine you have a farm and it's got 1 backhoe. This little unit would turn up on site, be unhitched. You can get, let's say, 9 or 10 refuels from that, and then it would just be replaced on demand. And so it's as simple as that. You plug it in. It's a quick refuel, and it should look and feel the same as diesel. Now, my background at the previous business I mentioned, NanoSun, we did this for on-road vehicles with a much larger containerized solution for buses and trucks. So it's a space I know quite well. This is a sort of smaller, containerized, lower cost version. And so the model here is, it's a kind of drop and swap model, totally similar to a diesel Bowser. There's also a model for a larger site where you can actually fit 8 of these containerized mobile refuelers on the back of 40-foot on a 40-foot trailer, and we've got an electric Moffat. It's either forks or it's actually a JCB quick hitch system. It takes both. You can actually see the quick hitch system on here. And so the other model is for larger sites that it's still drop and swap, but you can unload a couple of them, or you can unload 8 and again swap them over. And so this was trials last year. They had about 20 units out on sites, most of them building sites, both backhoe, load all, and generators. And you'll start seeing JCB, they'll be pricing out for these units shortly, and you'll start to see them being basically sold and delivered commercially from about midway through this year. So that's a little bit on my business. As I said, my background's really energy, and hydrogen is really electricity, and hydrogen is really an electricity story. And there's always questions about the price of hydrogen. In the UK, it's still going to be pretty expensive until HAR1 projects come online, which will be 27, at which point you should see, or you will see hydrogen normalize at a kind of HVO retail price, in the, let's say, £3 to £4. So that's not the delivered cost, that's the cost of just the fuel. And, if we could end up with a delivered cost of £8 to £10 per kilo, that would be amazing. And if it doesn't happen in 27, it'll happen shortly after. Germany is a little bit further ahead, and there are other countries further ahead still. I spent quite a lot of time in China. China are just living in the future when it comes to hydrogen. They have a low price hydrogen, but it's often because it's very dirty. And their approach has been, well, let's create the network and the infrastructure, and then we'll steadily green that hydrogen over time. So there's a little bit of background on me and the project. Always happy to chat, and hopefully that's been helpful.
Neil, that's excellent. Thanks very much. Just to give us an indication of where things are going in terms of not only the engine technology and the fuel availability, but also the key issue when it comes to agriculture, actually getting that fuel onto a farm.
Yeah, no, and very, very, very happy always to chat. So hopefully that's been helpful.
Great. Okay, well, we'll move on. We'll pick up questions at the end for all 3 of our speakers, but we'll move on now to Kit Franklin. Kit has been involved with the RASE Pure Farm of the Future project for some time. He heads, or he's a fellow of the engineering department at Harper Adams University, and was responsible for the hands-free hectare and hands-free farming project, which was really instrumental in demonstrating the potential for robotics at a farm level. And he's going to talk about robotic-enabled farm technology. Over to you, Kit.
Perfect. Thanks, Richard. Hopefully my slides are coming through and I'm coming through clearly. Yeah, great. So I won't say any more about who I am. I'll just crack on. If I can get my slides to cycle through. There we go. So as has already been mentioned by Alistair, this was the John Deere that he was referencing, whereby we have a demonstration of the sort of difference in energy density between diesel and lithium in an image here. So lithium is sort of circa 25 times less dense than diesel. Now that is pre-losses. We have to remember that obviously when we burn diesel in an engine, there is much efficiency lost, whereas an electric tractor running on lithium, you would expect lesser losses. But still, John Deere, who've had a go at this, created this 6R equivalent, so an equivalent unit to their 120 to 250 horsepower tractor. So it was built on one of those chassis. But as was already said, rather than weighing the sort of 9 tons that you would expect for a tractor of that size, it ended up weighing 18 tons and would only offer a sort of 10-hour operation time at 80% load versus 12+ hour days that would be completely expected and standard for a conventional diesel powered tractor of the similar size. So that really shows the difference in energy density and the key issue of trying to move agriculture and tractors as we know it to electric powertrains. So John Deere again have done some work on this, and again this was mentioned by Alistair, whereby they've put essentially a tractor on an extension cable, and then even come up with a concept of then linking multiple vehicles together in the field via sub extension cables. Now this obviously gets over the issue of having to carry all that mass of energy, but seems as an engineer, I can sit here and this just looks like an engineering nightmare, a logistical nightmare, trying to navigate a field whilst not at any point managing to tangle up a high voltage power cable or run it over, etc. So a real issue of how do we ever get electrification to work on these large scale tractors. Well, maybe we don't, and compact tractors are certainly leading the way in electrification. So here's a selection. You've got Taffe, an Indian company. They've brought to market a 30 horsepower equivalent sort of electric tractor, which you can now buy here in the UK, I think, as of about now, they're selling them. You've got Monarch Tractors, which is a startup based in California. They are selling these units internationally, have just opened up a European headquarters. I'm not exactly sure of the equivalent size, but I think it's about a 50 horsepower equivalent machine. And then you have Fendt, who have their 70 horsepower equivalent orchard or vineyard tractor, you can see here. Now, these units, and in this size and scale, offer usable a usable sort of runtime. So we're getting typically 5 hours of runtime on a 1 hour fast charge. So in the typical sort of duty cycles and tasks that these sort of tractors would be put to, this could be an acceptable runtime. If you think of something like a horticultural, a sort of polytunnel environment, then you could maybe run the machine up and down for 5 hours, have a lunch break, come back after lunch, and you've got another 5 hours of energy to use. So in that sort of horticulture and say viticulture environment, there is a sort of a use case that makes sense for these tractors in the way in which we currently operate machines with drivers involved. But if we consider that the limitations that can be overcome by getting rid of a driver, which is what I've kind of ended up spending my career talking about, you can see here a video of the hands-free hectare system where we've got 2 small-scale 30 horsepower tractors. 40 horsepower tractors, sorry, working in a field, establishing, this was actually a crop of beans, working alongside a 300 horsepower tractor pulling a 4-meter machine. So we've basically got 2 small scale, lightweight machines doing the equivalent work of one very heavy, very expensive machine. And this is, you know, essentially what happens when we embrace automation and we sort of get away from the limitation that we have in agriculture, which is a limit of human involvement. I'll just play that video again while I keep talking. So if we get rid of that human, or if we don't need the human on every seat, we can shrink the machine, and then those compact tractors could do operations that are useful on that sort of large scale agriculture. We can also start bringing in unusual work rates and unusual working periods. So we can reimagine the sort of 9 to 5, or obviously in agriculture, it's often a lot more than that. I'm fully aware of that. But ultimately, if we've got an autonomous machine, it doesn't have a preference to working in the day or in the night or any of those things. So maybe we can move to a sort of a slow and long approach. So maybe we accept that work, rather than turning up to a field and getting the job done in 3 hours, we can accept turning up to the field and the job taking a few days to happen because there's nobody tied to that machine. So that's the sort of opportunity that small machines in an autonomous environment offer, and electrification would certainly be a way of powering those smaller machines. Just something else as a side point, there is a sort of biodiversity opportunity here, because if you look at the graph at the bottom, you can see the efficiency benefit of small machines in small fields. So the big machines we currently use, which is represented by the sort of orange bars, are very inefficient when it comes to small field agriculture. So if we want to move to a biodiverse environment with more hedgerows, more field trees, then smaller is going to be the way to do that. So as I've just said, if automation allows us to reimagine the sort of timescales of farming, then we can also completely turn our back on the model of a tractor at all. And we can think about, you know, what does a tractor really mean? Well, a tractor is just a vehicle for doing operations in a field. So here we see the farm droid. Now, the farm droid is a very slow machine. It travels at 1 kilometer an hour tops. It's 3 meters wide, so it's covering about 1/3 of a hectare an hour. So a very slow, methodical machine, but this is allowing for the growing of high value crops using purely solar power. So this machine, by embracing slow, long work times rather than quick get it done work times, has allowed us to move to a solar powered machine. In the UK environment, this machine will work for about 20 hours in a 24-hour window on a spring day in the UK. So the solar is gathering enough power, and it does have an onboard battery, that it will run for 20 hours on a spring day here in the UK. There's about 20 of them in the UK, and there's about 500 of these machines across Europe. So as I say, by embracing automation and reimagining what farming can look like, we can actually find a way that electrification, sort of automation essentially enables a move to electrification. And again, I would see this machine as a great opportunity for a more diverse crop rotation on a farm, because it suddenly allows you to grow high value, high input crops, because it's that particular machine is seeding and weeding. So you can plant a lettuce crop, let's say, and it will go back through and it will hoe around that lettuce crop, all with the purchase of one machine for a fairly reasonable figure of about £80,000. I think the government just announced that the sort of grant system was going to come back online, and you can even get a grant to buy one of those machines. So again, just to reiterate the key point, if we're not limited by humans driving machines that therefore force us to have these big, huge machines, then we can reimagine things and design and develop machines that work on an electrical platform. Just to finish off then, as a final slide, if we think of things like spraying, and we've got a potential move to drone or UAV spraying, very common in China and Asia. We're obviously facing greater sort of environmental legislation, so we need to prove these machines work, but there is work being done on that. But again, if we can move to a sort of an aerial application, or as this video shows in the bottom, where we're spraying with spot spraying system where we can cut the chemical. The robot operating in the bottom here is managing to control a dockleaf population in a grass field by using around about 10% of the chemical that would otherwise be used to broadcast apply on this field. So again, this particular machine is a diesel machine, but there is no reason that a machine carrying a small amount of chemical to go spot spraying couldn't once again be an electric option. So as these new technologies come through, as potentially drone spraying comes through, as potentially spot spraying comes through, it opens the door to go, well, actually, we don't need a self-propelled sprayer carrying 5,000 litres anymore. We could have a machine that only carried a couple of 100 litres, and that machine could then be a electrically powered machine and maybe a solar electric machine, as we saw with the farm droid. So I will wrap it up there, Richard. I hope that was a good little roundup of how automation can lead the way and sort of enable electrification.
Thank you, Kit. That's brilliant. Great to see the way in which the sector is evolving, and I think highlights the sort of dichotomy that we need to look at in agriculture. Are we going to be able to switch a significant proportion of farm vehicle activity to electric, to robotics, or are we going to need heavy duty tractors with internal combustion engines for well beyond 2040, 2050? And I think that's a challenge that agriculture needs to address in conjunction with other stakeholders. So we have time for questions, so open the floor if people want to either put their hands up or put a question in the Q&A box. I'll endeavour to relay them to our speakers. So question, I'll pick one from Mike Willicott, who was involved in the Farm of the Future report. Welcome, Mike. In the current environment of drill, baby, drill, BP withdrawal from renewables and OEM reluctance to invest in new powertrain alternatives, how will this impact on the economics of diesel alternatives for the farm? Will the successful transition away from diesel only happen if there are government incentives or regulations? So, Alistair, would you like to pick that up first, and we'll...
Yeah, okay, Richard. It's a great question, and it's one that's certainly in my old role at CNH we were struggling to address, recognizing that at the end of the day, a farm has to remain profitable if it's going to be green for any length of time. Otherwise, it's out of business. So within the CNH and the what ended up being the Bennamann partnership, the interest we saw from the Bennamann activity was the production of fuel and energy on the farm became almost the priority rather than the actual tractor itself. It was the Bennamann system, and there are other systems that are very similar to that now coming through. But the system actually became more profitable for the farm, and they have a number of quite a few now farms actually practicing it. One or two have been running for 3, 4, 5 years, and the farms have actually become more profitable because of better manure management, being able to run regenerative agriculture in a more logical manner, and so the use of the tractor has become it's become a nice to have on top of the activity of becoming green, not a reason to drive it. The issue we saw with other fuels at the moment, and there may be changes as technology improves in the future, but the issue was if you were trying to force farmers to put in very big, expensive either electrolyzers or grid activities, we did look at getting methane, grid methane put on farms at one point within CNH, but when it came down to it, of course, even though the gas pipes ran across the farm, if you wanted to put a gas pipe in at the farm buildings and weren't there, farmers were getting charged anything at least £1,000 per meter to put a gas pipe in. So suddenly what appeared to be quite cheap fuel suddenly became really expensive because you had a sort of 200 meters of gas pipe to put in, So you had £250,000 worth of investment before you even started. So I think it's important to look at the whole energy ecosystem, not just at the vehicle itself.
I think that's a key factor in terms of, Neil was talking earlier, replicating the diesel Bowser system. I mean, Neil, do you want to pick that up and say, is there not really perhaps a need for OEMs that are looking at gas and alternative fuels to work together to look at distributed infrastructure within the rural economy?
Yep. I mean, there's a danger I'll get lost in this question because you can rove everywhere on this question. I think to answer the question, I think legislation always helps, right? And
Yeah.
you're seeing the government fumble around with the EV industry, trying to get the car industry clear on what the heck is going to happen. So legislation absolutely helps. I think there's probably more collaboration going on behind the scenes with the OEMs than people realize, right? Because they're all facing the same problems. They do actually talk to each other. You might not believe it, but they do. And something like a hydrogen ICE engine. If you track my IAPS report, I talked about, and if you look at the potential for ICE, maybe as an interim solution, right? It makes a lot of sense. So actually, the reason and by the way, I'm totally agnostic. I just want to get the best solution for the customer. But an ICE hydrogen engine is quite a nice sort of like point to go for because you drop it in, right? It drops in. There's no change to the backhoe. You drop it in and it goes. You could drop it into a Toyota Hilux or a Sprinter, and I know that because they've done it. Right, the chairman's like, stick it in my Hilux, and the engineers are like, oh my god, stick it in the Sprinter, oh my god, and it's possible. So there's more collaboration that goes on, I think, around something like a hydrogen ICE engine than people might realize. And I think all of these OEMs are running multiple streams because they're sort of dealing with legislation, mineral availability, what's the right solution when they're trying to read the tea leaves. And so most companies are running multiple strategies, but I think I would look to China. Just there's a bifurcation there where, I don't know if anyone's been to China recently, but cars are just electric. It's absolutely bonkers. There's brands, I asked like my people that travel with me, what brand is that? And they have got no clue. That's how many electric vehicle brands there are. And for trucks and buses, it's hydrogen, particularly in the north. And as I said, the hydrogen is not very clean, but it's a great solution. And obviously marine, right? And so I'm quite a big believer in, the right solution for the right job. And I think hydrogen, although it's got so many headwinds because of production, availability and moving around, but it's a great answer for some applications. But legislation is very helpful, and I hope the government continues to invest in the HAR projects, and I hope they continue to provide some really useful guidance, like clear guidance to the car industry.
Great, thanks, Neil. Kit, in asking you to pick that up as well, can we also pick up Mike's question, which is really highlighting the fact that electrification of the grid on farms is a major issue, and what are we going to do to be able to get the better electric supplies onto farms to actually enable the sort of vehicles you're talking about?
Well, okay, that's quite a good one. So, going back to drill, baby, drill, and Trump, I guess my gut reaction, and again, this is me talking well out of my expertise, but just from what what my brain would say, is that if suddenly the US dumps more oil onto the global market, then it's going to bring prices of oil down. Therefore, the result of that is farmers are only going to do what makes sense in their back pocket. And if suddenly it's cheaper to run diesel, then the idea that they're going to suddenly look to take on more risky and new technologies is going to drop out of the way. Now, then I would also say, again, my gut reaction would then be that we would soon see the end of red diesel as a thing in this country, and there would be suddenly a big tax to pay. Drill, baby, drill has a massive potential to change how we change, without a doubt. How do we get electric onto farm? Well, I think we have to embrace, and was mentioned in some of the talks, is on farm generation, be that solar on your sheds, battery storage, and valorization of waste streams. So the small scale AD plants, stuff like now I've forgotten the name, but the sort of containerized AD plants and that sort of thing are clearly ways to go that mean, if you could end up with a system where you've got a circular farm system, why wouldn't you do that? If you're running a dairy and you could have a containerized AD system that generated either enough methane or enough electric, depending on how you tune that device, to either run an electric load all around the farm or a methane load all around the farm, or turn it into hydrogen and run a hydrogen, I don't see why. That just seems like the way that we're going to go. Grid connections are always going to be an issue, but we're our own worst enemy, because how many farmers are going to be waving in the diggers to put better grid connections across their land? Yeah. So I think we have to be careful that we're not moaning about grid connections when potentially we're some of the barriers to decent grid connections. Sorry if that's a slightly controversial thing to say, but I've had a lot of dealings in my personal life with farmers and grid connections. So yeah, there's a few points to muse on, I guess.
Good. I suppose just to pick up at this general question, we have this dichotomy between electrification and gas fuels. We obviously need both. Do we need maybe more collaboration on the pathway to hydrogen by promoting biomethane as a stepping stone to hydrogen? Alistair, is that something you could pick up?
I think there is sort of some close similarities, as I indicated. Sort of various bits of work that I've been involved with indicate that a methane tractor and a hydrogen tractor technically can be very similar. So from a manufacturer's point of view, one of the risks that we run is that at the moment everything's diesel from sort of, I don't know, 14, 15 horsepower above. Everything that is run on diesel. Our danger is we start sort of having different sectors, they have different fuels, and we don't think about the end customer, that suddenly he goes from having one diesel tank in the yard to he needs a large generator for one bit, he needs a methane tank for the next range of tractors, and he needs a hydrogen tank for another range of tractors, etc. So suddenly he's in a bit of a mess. So we need to try and commonize as much as we can as manufacturers. Otherwise, we're not asking the customer to choose, if you like, different colors and different dealerships. We're asking them to choose different fuels and be driven in that manner, which is a real danger and a real problem. So there may be a split that some farms use everything under sort of 200 kilowatts, and we may end up having 2 fuels per farm, but even that sort of runs into a bit of a danger, because it's just adding cost to the end user.
What about dual fuels?
Dual fuel is interesting, but I think from a machine manufacturer, it would be interesting, and the end customer, if you had the same product that would run either on methane or hydrogen with either very little or a dealer type conversion that sort of says the base cost of the machine is the same, and with small changes it can be made to run. I don't sort of dual fuels advantage in the field is very limited. I mean, as CNH, we run various dual fuels of methane and diesel, extended the range, but it complicated the machine quite considerably. And unless you can get cheap fuel, and grid methane is not cheap, and so as CNH, we very much moved away from the grid point of view and sort of said it's farm produced methane from waste products that actually makes the sense. Putting grid methane into a tractor is, quite honestly, financially it's bonkers.
And also it doesn't need to be the quality level you need for the grid to go into a tractor.
No.
Neil, can I just pick up on that with you? I mean, do you see scope for what you're doing with JCB and hydrogen? And obviously JCB are very focused on hydrogen, but given the sort of inter transition between diesel and gas fuels, does your sort of technology model potentially also work for for other fuels on farms, particularly maybe biomethane?
I mean, probably not biomethane. I was just gonna probably not biomethane, but I think that the challenge with and so for those of you who don't know, JCB have electrified the small end of their range, so you can buy an electric XYZ small, digger and bucket and whatever. They're more expensive, right? Because it does require total retooling, and the problem is it's a physics problem. Electricity just does not work. Sorry, electric EV does not work well for big heavy machinery. It just doesn't. It just doesn't. And at a very macro scale, I think again we should save our lithium and stick it in cars and small lightweight vehicles. That's just my personal view, and go for a gas for the big stuff. Particularly in an industry where, I mean, and this is your methane point, which is like, it's that, commercial are used to sticking a nozzle in and squirting some fuel in. It's such a basic thing. But when I was working with the bus drivers in Cologne, they'd turn up with the bus and they're like, take the nozzle, stick it in the bus. It beeps and put the nozzle back. We don't need to train anyone to do that. You don't need a grid connection. You don't need to worry about continuity of supply for lithium, right? It's simple. And I'm not saying it's a forever maybe solution. I think I've talked about fuel cells. I'm very punchy on the potential for fuel cells, but as an interim step, I think it's good. And batteries are always they're tough, right? And I do love the Monarch story is one that I love, and I know the Monarch team, and because it's being lightweighted, that's smart, right? Because you're working the physics problem. So I don't know if that's a helpful response, but that's my personal view on things.
Yeah. Kit, do you want to come in on that?
I was just going to say, I think there is this ultimately scale thing, and maybe it also goes back to the question you put to me before about grid connections. I think ultimately, if the electrification ends up in the smaller machines and things like the small scale load telehandlers and loaders, and it ends up in field robots that are small or small compact tractors, then probably the grid connection that most farms have got would be sufficient anyway. The grid connection is only going to be an issue if we're going to try and make an electric 200 horsepower equivalent. But as has been said, as I said, the physics doesn't work, the mass of the battery doesn't work, the sort of duty cycles don't work. So I just don't think that's going to be a route we end up going anyway. Basically, I think electric battery stuff will end up being in small yard-based vehicles or compact style tractors or robots that are yet to be imagined.
Yeah. Because I mean, one of the issues with EVs, of course, is the weight issue has been highlighted, but it's also the inflationary impact. Neil, I think that was one of the drivers for JCB, is trying to produce a powertrain that was not going to be hugely inflationary for the end user.
Yeah, and it's as simple as that. And they're good at what they do, right? And they've got 80 years under their belt, and they just want to keep it simple. And and that's really, they brought me in, and my instruction was, make it simple, Neil. Make it simple. It's got to be a diesel Bowser, but not diesel. It's like, do not make this complicated. And I love that as direction, right? Because very clear on what's required.
And you seem to have achieved it as well, which is great.
Yeah, and I guess when I was drafted into NanoSun, which was the on-road pre-runner really to what I'm doing at HiKit, it was simple there as well. I mean, the technology behind it is actually quite complicated. It's all around very high pressure, 630, 700 bar tubes, and then, cascading pressure, and then ultimately delivering that safely into a target vehicle, making sure you know what the hell you're plugged into. So there's quite a lot of technology, but at the end of the day, you just want a nozzle, and that's it. And I think if you watch this little bit of film I was talking about, you'll see King Charles, putting the nozzle in the machine. And I think it was funny. I sort of laughed because that's, if he can do it on spec, then, there is some hope for us all.
Yeah, you don't have to wear a hazmat to do it.
Yeah, exactly.
There's a question we've probably got time for a couple more questions. A question from Rob Merrill. Would you like to see any changes to the regulatory landscape that impact on transporting hydrogen or methane around. He's thinking particularly of ADR. Alistair, do you want to pick on that? Because I think making it simple also needs simple regulation.
Yeah, it's certainly an area that's a major problem, because the ADR rules mean you can only carry a very small amount of gaseous products with you. So I think really the regulation needs to catch up with the development of the alternative fuel activities, and that goes. I mean, people talk about battery swapping, but just moving batteries around, if you want to start doing battery swapping, is another challenge that isn't covered currently by legislation, or not easily by legislation. I know at my time at CNH, there was a number of things that popped up that technically in the ag side we could have got away with, but my legal team quickly pointed out that we had some close connection with Iveco, and we had to do best practice. So we had to follow the on-highway rules, even though they technically didn't apply to agriculture. So I think, yes, regulation needs to catch up with where technology is going and give us some guidance. Otherwise, we're all developing things that, when you come down to it, can't be used.
Neil, do you want to say anything on
Yeah,
that?
I think it's a spot on answer. I was just going to say that I think there's other countries in Europe that are getting pretty good at this. So I think Germany, if you can, my general view of business is, if you can succeed in Germany, you can do it anywhere, just because they're so exacting.
Yeah.
And the German setup for certification is just, it's a bit more local and a bit more specific, and actually that's helpful, right? So you have to build relationships and explain what you're doing, but I think you end up in a sensible place, or that's my experience anyway. So yes, legislation, regulation has to catch up. I think it's moving in the right direction, and at the end of the day, they are there to make sure everyone's safe. So I get it.
Yeah, I suppose, Kit, the regulation isn't the issue holding back the electric side of things. It's more actually getting access to three-phase power and distribution through the available network. But if we do see electric as a future opportunity for agriculture, how are we going to overcome those issues?
Yeah, I think if I go back to my premise of what I was asked to speak about in terms of automation enabling electrification, I think we do have to think of legislation and make sure that that people are confident that what they're doing is safe and legal and all those things, because we do have a bit of a sort of grey area in law. We've developed a British standard on the use of autonomous vehicles, which is critically on the use of them. It's not on the manufacture of them. So if you wanted to go down the autonomous vehicle route, there are codes that you can follow to show best practice and safety, and insurers are all happy to insure them now, seemingly. So it's really important to get that right, though, because we don't want people to be turned off by the fact that there's a big uphill battle of paperwork that comes with the adoption of a new technology.
Yeah, and that's why we need more on-farm demonstration of technologies as well. I think we're sort of we've gone over our slot, but I'd just like all three of you to just end up with any sort of key points you'd like to make in terms of what's actually going to help the farmer to actually embrace the transition away from red diesel, and what do we need to do to sort of move that forward in the next few years with demonstration and other opportunities to sort of bring the farmer into the discussion. So perhaps we could end on that, starting with you, Alistair, and we'll go through the group.
All right. Well, for me, I think it's a case so we have to produce solutions for farmers that actually increase and improve their profitability. I think Kit said it earlier on. No, I think most farmers believe they're doing green things at the moment, and that they can. They're not just going to start spending a lot of money to run a environmentally friendly product if it's going to mean they're bankrupt or out of pocket, because unfortunately trying to pass the cost of this equipment on through a kilogram of potatoes or carrots in Tesco's is not going to happen. So unless we can show that there's an improvement in profitability and an improvement in lifestyle for the farmer, then it's not going to fly.
As we said in the Farm of the Future report, you know, you can't be green if you're in the red.
No.
Kit, do you want to pick that up as well?
Well, yeah, I agree with that. I guess my point would be to farmers to just be willing to expand your horizons. You know, if your viewpoint on the machinery you use is that it needs to look the same as it does now, do the same as it does now, i.e., go into a field, complete a field operation in 4 hours, go home and sit in the shed for the rest of the day, or, you know, extend that to a 12-hour day, whatever you like. But you know, if you're determined that your machine looks and does the same as it does today, it will end up being a gas-powered machine. If you're willing to expand the sort of your mindset and consider new ways and new time frames, as I say, slow machines that live in a field rather than visit a field, then electrification and automation is there, and there's plenty of companies offering it.
Neil, do you want to just finish off from your point of view? Obviously, you're perhaps less connected with agriculture than our other speakers, but you know, the construction industry is also a low margin industry that can't afford, you know, huge inflationary costs for its machinery. So
Yeah, I mean, I think it's been covered. It's cost and simplicity, right? Because at the end of the day, there's an operator that's got to be able to do this stuff. I think my build on construction is, and I almost answered the question earlier with this, forgot, is there are for the very big constructors or the very big plant hire companies and the very big projects, there is a commitment, sometimes contractual, to decarbonisation. And so I think at that very high level, we'll see, probably starting with projects, I don't know, Lower Thames Crossing, things like that, where they will use this type of choice because it really does quickly make an impact to their scope. Sort of ditto something like an airport, right? It's a bit away from farming, but you know, an airport really hard to obey. Okay, we've got 100 generators, let's swap those out, and the telehandlers. So I think where there are brand commitments, we'll see movement in this space, and hopefully it'll trickle down. That's, you know, without strong legislation, it's either legislation or it's brand, and those are the two drivers basically at the moment. But yeah, I mean, I'm excited, and I think everyone on this call is trying to do good things and make a difference, and that's what motivates me. And I think we'll get there. And you know, I think if the government can pull its EV target back in from 2035 to 2030, I think, you know, although it's not connected to farming, it makes a difference. So I think it will be interesting to see what this government does next, and ditto with the hard bids. So
great. Well, look, I think it's time to draw things to a conclusion. First of all, big thanks to Alistair, Kit, and Neil for spending the time with us and sharing their thoughts. Thanks, Tash, to you and the team at Raise for organising this. And thank you to everybody who's attended. I see attendees are dropping off a bit now, so that's a good time to wind up. I think just to say that, you know, Raise is committed to continuing dialogue and discussion around the decarbonisation of farming and around the transition of agriculture to more sustainable and circular practices. So we'll continue to do events on this and other aspects of farm decarbonisation under the Farm of the Future report. So do watch this space. We will be circulating the presentations from our three speakers. So if I could ask everybody to give a big virtual round of applause to Alistair, Neil, and Kit. And thank you all for attending.